Let us now dive into lesson 7.8. We're going to talk about evaluating definite integrals by the process of substitution. And so let's just dive right into it. A lot of this lesson is going to be mechanics. We're going to teach you the mechanics of u-substitution with definite integrals. We've already done that with indefinite integrals. But remember, when we did this with indefinite integrals, we still had to substitute back, which means we had to conclude with a function of x. That doesn't need to happen here because all of the values we're going to get are numeric. They're numbers. And so it turns out when we do a transformation from x to u, we can also transform the limits of integration themselves. And that means that we'll get an integral of u which yields the same value that the integral of x would give also. And that's pretty cool. Okay, let's look at the first example. The integral from 0 to 2 of x times x squared plus 1 all cubed times dx. Notice the x in the front is not cubed. Let u equal x squared plus 1. This means that du is 2x dx, so 1/2 du equals dx. But we don't stop there. We now also want to transform the lower and upper limits of integration. So if u equals x squared plus 1, think this through, then u must equal 1 if x equals 0. And u equals 5 if x equals 2. So now we get a transformed definite integral. The integral from 0 to 2 of x times quantity x squared plus 1 cubed dx is the same value as 1/2 the integral from 1 to 5 of u cubed du. Well, that's 1/8 u to the 4th evaluated from 5 to 1, 78. And there it goes. This stuff is pretty cool. Now what we're doing is we're learning the mechanics of it. This leads us to a cool little theorem. If g prime is continuous on the closed interval from a to b, and if f is continuous and has an antiderivative on the interval containing the values of g of x for x between a and b inclusive, then the definite integral from a to b of f of x g of x times g prime of x dx can be transformed into an integral of u from g of a to g of b of f of variable u times du. And that's the theorem we're using today. Let's take the integral from 0 to 3/4 of dx over 1 minus x. Let's make a quick note first before we do this. The integrand is undefined at x equals 1. But we're okay, because 1 is not in the interval of integration. We're going from 0 to 3/4, so we're safe. We're nice and continuous. Now, if u equals 1 minus x, this means that negative du equals dx. Now we transform the limits of integration. If u equals 1, or excuse me, u is equal to 1 if x equals 0, and u is equal to 1/4 if x is equal to 3/4. This gives us the integral from 0 to 3/4 of dx over 1 minus x dx, I forgot to write a little dx, and oh no, there it is, duh, sorry, equals the negative integral from 1 to 3/4 of 1 over u du. But we swap the limits of integration because 1 is larger, and that gets rid of the negative. So the integral from 3/4 to 1 of 1 over u du is the natural log of the absolute value from 3/4 to 1, and that's equal to natural log 1 minus natural log 3/4. Using the properties of logarithms, that's how I get natural log 4/3, which is natural log 4 minus natural log 3. Let's find the definite integral from 0 to pi over 8 of sine to the 5th of 2x times cosine of 2x dx. Notice the cosine is the derivative of the sine, and so therefore I'm going to let u equal sine of 2x. So therefore du would be 1/2 1/2 du would equal cosine of 2x dx. But now we transform the limits. If x is 0, then u is 0. And if x is pi over 8, that means u is the square root of 2 over 2. This transforms the integral. We now have 1/2 the definite integral from 0 to square root of 2 over 2 of u to the 5th du, which is 1/12 of u to the 6th evaluated, square root of 2 over 2 minus the 0, and we get 1/96. Let capital T equal 70 minus 30 e to the negative 0.5 t. Let this be a model for the temperature in Fahrenheit of a glass of lemonade, t hours after being placed in a room with a constant temperature of 70 degrees Fahrenheit. Note that the limit as t goes to infinity, as time marches on, that's going to be 70 degrees. That makes perfect sense, because as time marches on, we would expect the lemonade's temperature to approach constant room temperature. Makes perfect sense. So temperature T does not go to infinity, it doesn't go to negative infinity, it approaches room temperature, which means there's a horizontal asymptote pair. Find the average temperature of the lemonade over the first 5 hours. Whenever you're asked to find the average value of a function, you do 1 over the length of the interval. So average temperature T is 1 over 5 minus 0 times the integral from 0 to 5 of capital T, the function capital T. Now I separate the two integrals, and the first one, 0 to 5, 70 dt, integrates very easily. That's just 70t, and then I evaluate it and I get 350. The second integral, it's possible to do that without u-substitution, but this is precisely where I'm going to use u-substitution. So I'm going to let u equal negative 0.5t, so that means that negative 2 du equals dt. U will be 0 if x equals 0, and u will equal negative 2.5 if x equals 5. That transforms the one integral into negative 60 integral from 0 to negative 2.5 e to the u du. Swap the limits of integration, so that makes it 60. So 60 and the integral from negative 2.5 to 0 e to the u du. All said and done now, after we calculate this, we get the average temperature of the lemonade over the first 5 hours, that's the interpretation here, is 58.99 degrees Fahrenheit. And that is the lesson. So what did we learn today? We're learning how to do u-substitution on definite integrals. How is that different from u-substitution on indefinite integrals? Answer, in this lesson, you don't have to substitute back so long as you transform the variables when you do the u-substitution, because the integral in u will give you the same number or value, as long as you do it correctly, that the integral in x would give you. Whereas in indefinite integration, when we did u-substitution, we desired a final answer which was a function. It was an integral curve. It had a plus c, so it had to be a function of x, and that's why we had to substitute back. Other than that, the process is the same as we learned in the previous lesson. God bless you, wherever you are today.